It's been around for centuries, but we didn't know much about it until just recently. This is the South Pole Hurricane on Saturn, the largest storm in the solar system. And we've only just uncovered what keeps it going. If you live on Earth, then you've probably seen a hurricane or a cyclone. These storms are basically the same thing. They're spinning vortexes of awfulness powered by warm water vapor that rises as it cools, forms clouds, and dumps loads of precipitation. They typically last for days or weeks, but compared to Saturn's South Pole storm, they're more like a light breeze. That's because Saturn has had a giant storm raging at its South Pole for hundreds of years, maybe even thousands. The first human-made object to spot it was the Voyager 1 probe back in 1980, and it has been there ever since, whipping around at 180 meters per second. That's 648 kilometers per hour, and here's the really weird part. It's got an eye just like the ones we see on Earth, but unlike Earth's cyclones, the eye of this storm isn't calm and clear. It's full of clouds, and it's almost as wide as our entire planet. In fact, this whole storm is bonkers big. If you tried to fit it onto Earth, you could stretch it over almost 3 continents. It's also way stronger than any hurricane that hits our planet. Saturn's storm can reach 500 meters per second, which is 1,800 kilometers per hour. And yet, despite its immense size and strength, it hasn't moved much at all over the past few decades. And that's not just because it's on a planet without any solid ground for it to get caught on. There have been times when it looks like it might move, like when in 2010 it started to make a loop around a smaller storm. But ultimately, it just kind of stayed put. There are some other huge storms on other planets, like the Great Red Spot on Jupiter. But those, too, eventually dissipate and reform somewhere else. Meanwhile, Saturn's storm has stuck around in pretty much the same place for as long as we've been watching it. And that makes it all the more weird. I mean, we still don't know exactly how these things form in the first place. So it's hard to say why this one doesn't go away. But we do have some theories, and they all come down to heat. You see, here on Earth, most of the energy that fuels our weather comes from the sun. As the sun's rays hit our surface, some's absorbed by the oceans and then re-emitted as infrared radiation. And that's what drives our weather and our climate. But Saturn is so far out in the solar system that sunlight isn't nearly enough to power a storm like this. So instead, scientists think it must be powered by heat coming from deep inside Saturn itself. And they're not talking about the heat left over from when the planet formed. I mean, that's probably still there, but it would have dissipated by now. Instead, this heat likely comes from the planet's core, which is probably still super hot due to all the gravitational potential energy Saturn has thanks to its massive size and all the gravity wells that come with that. Scientists think this gravitational potential energy is being converted into heat as Saturn slowly collapses under its own gravity. Now, if that sounds familiar, it should. That's the exact same process that powers our sun and every other star in the universe. Basically, all that heat from the planet's core is sloshing around in Saturn's metallic hydrogen ocean, creating convection currents that well up and over and then collapse again and again and again. And the heat that comes out of that cycle powers the South Pole storm. Here's how. Just like on Earth, warm vapor rises from Saturn's insides, and then as it reaches the cooler surface, it condenses into clouds and falls back down as rain. But that's where the similarities end. On Earth, that vapor is water vapor. But since Saturn is so cold, it's probably ammonia ice crystals falling to the surface. But as that ammonia falls, it drags something else along for the ride. It's not super clear what that is, but scientists think it's probably hydrogen sulfide. And hydrogen sulfide is a really great cloud condenser. Once it starts raining, more and more of it, and the ammonia condense and fall, forming bigger and bigger ice crystals that eventually become thick enough to block some of the heat coming from below. And that creates a temperature inversion, a layer of cold above a layer of warm. On Earth, this can happen when a mass of warm air rises too quickly. But on Saturn, scientists think the sheer scale of the storm is what prevents the heat from reaching the surface. So there's this constant battle between the rising vapor and the falling ice crystals, and the result is this, an eternal storm. Now, sure, that's a little bit different from what happens on Earth, but once you break it down, it's actually pretty similar. We've got rising vapor, cooling, condensation, precipitation, and then more vapor getting dragged up and the cycle continues. It's just that on Saturn, everything is way bigger and way colder, and it's powered by an internal heat source. What that means is that while our weather is driven by changes in temperature and pressure, Saturn's storm is driven by gravity. And that gives us a new perspective on old processes, like take condensation, for example. On Earth, we usually think of it as something that happens when warm air hits a cool bit of glass. But on Saturn, condensation is what drives giant planetoid storms. And who knows, maybe studying Saturn's storm will help us understand our own better. After all, they do follow the same basic principles. They just operate on vastly different scales. So maybe we Lions learn how to predict our weather more accurately, or how to stop a hurricane from gaining strength. Or maybe we Lions just find out how lucky we are that our planet doesn't have a giant planetoid storm that never goes away. Thanks for watching this episode. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons. So, to all of our patrons, thank you for what you do to make this happen. If you're not a patron but you want to learn more about what that means, you can go to our support page. But either way, this platform is how we're able to share what we love doing with the world. And if you want to be a part of that, we've got all kinds of perks, from blooper reels to behind-the-scenes posts to a patron-exclusive podcast. The link to that is right here.